In the autumn of 1990, a caving team crawling through a mountain in southwestern France squeezed through a gap that hadn't seen daylight in longer than our species has existed. 336 meters in, well past the point where any hint of sunlight could reach, their headlamps swept across something that stopped them cold. Two large rings of broken stone, deliberately arranged on the cave floor, each piece snapped from the same kind of mineral column and stacked with obvious intention. Later dating would put those rings at roughly 176,500 years old. Built by Neanderthals, a species that hadn't yet met ours, working in absolute blackness a third of a kilometer inside a mountain, for a reason nobody has ever been able to explain. Not shelter, not storage, just an urge apparently to go into the dark and build something there. That single fact should bother you more than it probably does. Humans are a surface species. We evolved on open plains, under open sky, with eyes built for daylight and legs built for running across flat ground, not squeezing through stone. And yet at some point, long before agriculture, long before writing, before most of what we'd call civilization, we started doing the single most contrary thing our bodies were ever designed for, crawling into solid rock and staying there. Quick housekeeping before we go further underground. If you like this kind of deep dive into how humans actually figured things out, hit like, subscribe, and drop a comment telling me which piece of this story surprised you most. It genuinely helps the channel, and I read every one. This is Ken, and this is the story of how a species built for sunlight ended up building an entire second civilization beneath its own feet. One dug not all at once, but in stages, over roughly 43,000 years, each stage triggered by a different kind of hunger. Start with the part nobody had to invent at all. Long before any living thing had legs to walk into anything, the planet was already riddled with tunnels. Lightning striking desert sand fuses the grains into hollow glass tubes called fulgurites. Lava flowing beneath a cooling crust can drain out entirely and leave a hollow tube behind, sometimes stretching for kilometers. And water, given enough time, millions of years, dissolves limestone from the inside out, hollowing vast cave systems beneath entire mountain ranges. Every one of these processes had been running for hundreds of millions of years before anything with a spine ever wandered into the result. Nature built the first tunnels. We just found them. The earliest evidence we have of anyone actually using one of those natural tunnels comes from Wonderwerk Cave in South Africa's Northern Cape. A research team led by Michael Chazan of the University of Toronto and Leora Kolska-Horwitz of the Hebrew University spent years analyzing sediment pulled from roughly 30 meters inside that cave, and in 2012 they published something remarkable: burned bone fragments and ashed plant material, dated to approximately 1 million years old. Not near the entrance, 30 meters in, well past where daylight could ever reach. That's our earliest secure evidence of controlled fire being used underground, and it means Homo erectus wasn't just ducking into a cave mouth to escape rain. They were carrying fire deep into total darkness and staying long enough to leave ash behind. Before any tunnel was ever dug, humans had already learned the first lesson the underground had to teach. It could keep you alive. But the Bruniquel rings prove that survival was never the whole story. Nobody needs shelter 336 meters inside a mountain, in total dark, past any weather a Neanderthal could possibly have been sheltering from. Something else was pulling them in. Some early, hard-to-name draw toward enclosed space and depth itself. Call it curiosity, call it ritual, call it whatever you like. Whatever it was, it's the seed every later tunnel grew out of. Still, walking into a hole that already exists and cutting a new one where there wasn't one before are two entirely different acts. One is exploration, the other is engineering, and the first humans known to cross that particular line didn't do it for water or shelter or safety. They did it for the color red. On a ridge called Bomvu in the modern kingdom of Eswatini sits a site known as Lion Cavern. Archaeologist Peter Beaumont and anatomist Raymond Dart excavated it in the late 1960s and found something nobody expected. Around 43,000 years ago, Middle Stone Age people had driven tunnels directly into an iron-rich hillside to mine specularite and hematite, both forms of red ochre. They left behind more than 300,000 mining tools, dolerite hammerstones, stone chisels, picks. This wasn't a few people scratching at a surface outcrop. It was sustained, organized, large-scale digging, tens of thousands of years before anything resembling a city existed. And the prize at the bottom of it wasn't food or metal. It was pigment, for painting bodies, tools, and the dead. The first tunnel, deliberately cut by human hands, as far as we know, wasn't practical at all. It was symbolic. And that pattern, someone wanting something the surface simply couldn't provide, badly enough to dig through solid stone to get it, repeats at every major turning point in this story. By the Neolithic, that hunger had shifted to a very different resource, and the tunnels got a lot more ambitious. At Grimes Graves in Norfolk, England, Canon William Greenwell's excavations between 1868 and 1870 uncovered an industrial-scale mining complex, more than 430 vertical shafts, some plunging 12 to 14 meters straight through chalk bedrock. At the bottom, miners squeezed into horizontal galleries barely a meter high, chasing a particular seam they called floorstone, the hardest, most reliably sharp-edged flint available, untouched by frost or weathering because it had never been exposed to open air. They cut it with picks made from red deer antler and shovels carved from cattle shoulder blades, working by the light of hollowed chalk lamps burning animal fat. And they deliberately left columns of unmined chalk standing to hold the roof up, a load-bearing technique still used in mining today. No metal, no structural engineering, just people who understood, correctly, that the good stone was always underground and never on top. Belgium's Spiens site shows the same logic running at an even larger scale. Discovered in 1867 by Alphonse Briard and François-Léopold Corneille, this UNESCO World Heritage Site covers more than 100 hectares, with shafts up to 16 meters deep, opening into networks of vaulted chambers. And it wasn't a brief operation. Mining continued there for roughly 2,000 years, from about 4350 to 2300 BC, longer than the entire span of the Roman Empire. For 2 millennia, the underground wasn't something to fear. It was simply where the good flint lived, and people went down to get it as routinely as we'd go to a shop. Not every dig was about extraction, though. Around 4000 BC on Malta, someone started cutting into limestone bedrock for the opposite reason, to build a home for the dead. The Hal Saflieni hypogeum, found by accident during construction work in 1902 and later excavated by Father Emmanuel Magri and Sir Themistocles Zammit, is a 3-level complex covering roughly 500 square meters, carved entirely with flint, obsidian, and antler picks. Inside it is a space known as the oracle chamber, which produces a deep resonance at close to 110 Hz, a frequency that neuroacoustic research has since linked to measurable shifts in the brain's emotional and language centers. It's entirely possible that 6,000 years ago, someone carved a room specifically to change how the people inside it felt. That's not just a tunnel, that's architecture aimed directly at the mind, built with tools made from deer antlers. Everything up to this point had been driven by ritual or resource hunting. What came next was driven by something with far higher stakes, keeping entire populations alive in places where the surface simply couldn't. In Persia, sometime in the early 1st millennium BC, engineers developed a system called the Qanat, and it's worth understanding exactly how it works, because it changes everything that follows. You sink a vertical shaft, a mother well, down into an aquifer at the base of a mountain. Then you dig a horizontal tunnel sloping gently downhill from that aquifer toward a settlement on the plain, dropping in gradient by roughly 1 meter for every 1,000 meters of length. Every 20 to 50 meters along that tunnel, you sink another vertical shaft, purely for ventilation and for hauling out debris. Gravity does the rest. No pumps, no power, and because the whole channel runs underground, almost no evaporation, in a climate where open surface canals can lose up to 60% of their water to the sun. The Kasabe Qanat at Gonabad has a mother well over 300 meters deep, feeding more than 33 kilometers of underground gallery, built roughly 2,700 years ago, and it is still functioning today. The Zarch Qanat near Yazd runs more than 71 kilometers, fed by 2,115 separate shafts. In 2016, UNESCO recognized 11 Qanat systems across Iran as a World Heritage Site, including one at Moon, near Ardistan, that carries 2 entirely separate water channels stacked at different depths, running past each other without ever mixing. What made Qanats different from everything that came before wasn't scale, it was precision. You cannot dig one by feel. Too steep a slope and the water erodes and destroys the channel. Too flat, and it simply stagnates. The Mukunnis who built them developed real surveying methods, using water-level balance boards and plumb lines to hold a single consistent gradient across tens of kilometers of tunnel they could never see all at once. That's not digging anymore, that's applied mathematics. And that exact kind of precision is what made the next leap in tunneling possible, cutting a passage from both ends at once and trusting the two halves to actually meet. Around 701 BC, King Hezekiah of Judah faced a very specific military problem. An Assyrian army under King Sennacherib was closing in on Jerusalem, and the city's water source, the Gihon Spring, sat outside its walls, meaning that if the Assyrians took the spring, the city would die of thirst long before it fell to any siege. Hezekiah's solution was to cut a tunnel through 533 meters of solid limestone, rerouting the spring's water to a pool safely inside the walls, and his workers dug it from both ends simultaneously, guiding themselves toward each other in the final stretch purely by the sound of picks striking rock through the stone between them. In 1880, a student named Jacob Eliyahu, wading through the finished tunnel, found an inscription carved into the wall in ancient Hebrew script describing that exact moment. Two crews, working blind, calling to each other through a crack in the rock until pick met pick and the water finally ran through. That's a construction log carved in stone 27 centuries ago, and it describes people navigating underground by sound alone, tunneling before anyone had a word for surveying. About 170 years later, on the Greek island of Samos, an engineer named Eupalinos of Megara took that same idea and pushed it somewhere genuinely audacious. Commissioned around 530 BC by the tyrant Polycrates, Eupalinos needed to drive a water tunnel more than a kilometer through solid limestone under Mount Castro, too tall a mountain for the vertical relief shafts earlier builders had relied on. He dug from both sides, like Hezekiah's crews had, but he understood something they hadn't had to worry about at that length. Over 1,000 meters of tunnel, even a tiny surveying error would send the two headings past each other entirely, deep inside the mountain, with no way to correct course. So he built the error in on purpose. Partway through, both tunnels were deliberately angled off the straight line, a calculated dogleg that widened the zone where the two crews could still find each other to roughly 17 meters. When the headings finally connected, the horizontal miss was under 60 centimeters, and the vertical miss was next to nothing. Herodotus later called it one of the 3 greatest engineering feats the Greeks ever produced, and a full 20th century survey by Hermann Qanats of the German Archaeological Institute confirmed just how precise it really was. A geometry problem solved with iron picks and oil lamps, 5.5 centuries before anyone had a compass, let alone a laser. Water wasn't the only thing worth tunneling for. Sometimes it was an entire city. In 396 BC, during the 10-year siege of the Etruscan city of Veii, the Roman commander Marcus Furius Camillus ended the standoff by having his soldiers dig underneath the walls entirely, surfacing inside the citadel through the floor of a temple. From that point on, digging beneath an enemy's defenses became a standard part of ancient siege warfare, and the underground fights that resulted were some of the ugliest, most claustrophobic combat in the ancient world. At Dura-Europos, a Roman garrison town on the Euphrates in what's now eastern Syria, Sasanian Persian sappers tunneled beneath a defensive tower in 256 AD to bring the wall down, and Roman defenders dug a counter-tunnel to stop them. When the two passages broke into each other, the Persians were ready. They lit a mix of bitumen and sulfur, flooding the tunnel with choking gas. A 2009 re-examination of the skeletons found there by archaeologist Simon James of the University of Leicester identified 19 Roman soldiers and 1 Persian sapper who had suffocated within seconds, their bodies still stacked where they fell, very possibly the earliest confirmed chemical weapon attack in recorded history, and it happened underground, in the dark, in the middle of a tunnel fight. The Romans then did to tunneling what they did to almost everything else. They scaled it up until nobody else came close. Between 41 and 52 AD, under Emperor Claudius, engineers drove a 5.5-kilometer tunnel through Mount Salviano to drain Lake Fucino, using more than 30 vertical shafts, some over 120 meters deep, to let more than 80 separate crews dig simultaneously from dozens of underground faces at once. It took 30,000 laborers 11 years, and both Tacitus and Suetonius recorded it in their histories. Here's the number that puts it in perspective. That tunnel held the record for longest on Earth for over 1,800 years. Nobody beat it until 1871. An emperor the Roman elite openly mocked for stammering and clumsiness left behind an engineering record that outlasted nearly 2,000 years of everyone else's best efforts. Not every Roman tunnel worked out so cleanly, and not every review was glowing. In 37 BC, the architect Lucius Cocceius Octus carved a 700-meter road tunnel through the volcanic rock of Posillipo Hill, near Naples, connecting the city to Pozzuoli, and the philosopher Seneca, who had the misfortune of traveling through it, complained about the experience in a letter that survives to this day, calling it a prison with dimmer torches and worse dust than anything he'd endured. It may be the first one-star review ever left for a tunnel. Even more telling is what happened in 152 AD near Salde, in what's now Béjaïa, Algeria, where a military engineer named Nonius Datus surveyed an aqueduct tunnel meant to be cut from opposite ends of a mountain. The two crews missed each other entirely. One drifted north, the other south, tunneling past one another inside solid rock with no idea how close or how far they'd actually come. Datus was called back, recalculated the geometry, and had a connecting passage cut to link the two failed tunnels together. The whole embarrassing episode was carved onto a stone marker discovered in 1866, proof that even Rome's best engineers occasionally got the geometry wrong. For roughly the next 1,000 years, tunneling technology barely moved. The dominant method was fire setting. Build a roaring fire against a rock face, then douse it with cold water so the sudden temperature shock cracks the stone apart. Miners in Central Europe's Harz and Ore mountains and around Freiburg pushed shafts deeper using this method, developing mechanical ventilation powered by water wheels forcing air through hollow log ducts as they went. In 1556, the scholar Georgius Agricola documented the entire state of underground mining technology in a book called De Re Metallica, the most complete mining reference the world had yet produced. Then, on the 8th of February 1627, everything changed at once. At a mine near Chemnitz, now Banska Štiavnica in Slovakia, a Tyrolean engineer named Kaspar Weindl packed black powder into hand-drilled holes in solid rock and detonated it in front of a crowd of imperial mining officials. It was the first documented use of explosives to break rock underground, and in a single demonstration, it made every fire-setting technique obsolete. Gunpowder blasting spread across European mines within a few decades, and by 1679, engineer Pierre-Paul Riquet was using the same technique to blast the 165-meter Malpas tunnel on France's Canal du Midi, the first civilian transport tunnel ever built with explosives. But explosives only solved half the problem. They were excellent against hard rock, against soft, waterlogged ground, under a river, under a city. The earth simply collapsed before you could brace it. London had tried and failed repeatedly to put a tunnel under the Thames. The riverbed there was loose, saturated silt that caved in on itself. The eventual solution came from an engineer who'd been studying, of all things, a worm. In 1818, Marc Isambard Brunel patented what became known as the tunneling shield, modeled directly on the anatomy of the naval shipworm Teredo navalis, a creature that bores through solid ship timber using a hard shell on its head while simultaneously secreting a smooth lining behind itself, digging and reinforcing in one continuous motion. Brunel's mechanical version was a 90-ton rectangular iron frame divided into 36 cells across 3 tiers. Miners removed one small wooden board at a time, cleared a few inches of riverbed mud, replaced the board, and jacked the whole shield forward, while bricklayers built a permanent lining immediately behind them. His son, a young Isambard Kingdom Brunel, served as resident engineer on the project. The Thames Tunnel took 18 years. The river broke through 5 separate times. A catastrophic flood on the 12th of January 1828 killed 6 workers and very nearly drowned the younger Brunel himself, who was swept unconscious up the shaft by the surge. At least 10 men died over the course of construction from drowning, gas, and sewage contamination, and the project stalled for 7 straight years when the money ran out. It finally opened on the 25th of March, 1843, 366 meters of tunnel under a tidal river, built using a technique borrowed from a mollusk, and it's still carrying passengers today as part of London's overground network, more than a century and a half later. After that, the pace of change accelerated fast. Construction began in 1857 on what became known as the Frejus Tunnel, cutting through the Alps to connect France and Italy. Chief engineer Germain Sommeil introduced a compressed air rock drill in 1861 that pushed excavation speed from 20 or 30 centimeters a day by hand to over 2 meters a day by machine. And partway through construction, Alfred Nobel's newly patented dynamite arrived to speed things up further. The two crews met beneath the mountain on Christmas Day, 1870, after 13 years of work, off by less than 30 centimeters across a distance of over 12 kilometers, without a single intermediate shaft to check their bearings along the way. Sommeil himself died of exhaustion on the 11th of July, 1871, 2 months before the tunnel officially opened. He never got to see a train pass through the thing he'd spent over a decade building. The Frejus Tunnel broke Claudius's 18th-century-old record, proved that machine power could replace 100 men, and showed that a straight line through an entire mountain range could be surveyed with something close to a carpenter's precision. Every long tunnel built since owes something to what Sommeil proved in those Alps. In 1953, an American engineer named James Robbins built what's generally considered the first modern tunnel boring machine for the Oahe Dam diversion tunnels in South Dakota, and in 1956 he patented the rolling disc cutter, a design that fractures rock through tension rather than grinding it away, using a fraction of the energy older methods required. That single invention made it possible to bore through mountains at a pace that would have taken Claudius's 30,000 laborers centuries to match. And the tunnels just kept getting longer. Between 1988 and 1994, 11 purpose-built boring machines cut through the chalk marl beneath the English Channel, excavating over 50 kilometers of tunnel, nearly 38 of it under open sea, to link England and France. On the 1st of December 1990, Graham Fagg on the British side and Philippe Cosette on the French side reached through the final pilot bore and shook hands, connecting two countries that had been separated by water for roughly 8,000 years. The idea itself wasn't new. A French engineer named Albert Mathieu Favier had first proposed a cross-channel tunnel back in 1802. It simply took 188 years and several failed attempts to actually pull off. In 2016, Switzerland opened the Gotthard Base Tunnel, 57 kilometers long, reaching depths of up to 2,450 meters beneath the Alps, the longest and deepest transport tunnel on the planet. 4 heron-cacked boring machines, each longer than 4 football fields end to end, ground through more than 28 million tons of rock over 17 years, working in conditions that reached 46 degrees Celsius at the deepest points. 9 workers died building it. From antler picks scraping chalk in Neolithic England to 440-meter machines grinding through alpine bedrock hot enough to cook meat, that's the entire distance this story covers, in one continuous, unbroken line of people who refuse to stay on the surface. So, where does that leave the question we opened with? Humans never discovered tunneling in one single moment. It arrived in layers, spread across roughly 43,000 years, each layer stacked on a different kind of need. First came shelter, learning that fire and darkness could coexist, deep inside a cave that was already there. Then came ritual and pigment, at Lion Cavern, the first time anyone deliberately cut into rock instead of just walking into it. Then resource extraction at industrial scale, chasing flint through chalk at Grimes Graves and Spians for 2,000 years straight. Then survival infrastructure, in the Qanats that kept Persian cities alive across some of the driest land on the planet. Then precision engineering, as Hezekiah's crews and Eupalinos learned to cut from both ends of a mountain and meet in the middle with less than a meter of error. Rome scaled the whole enterprise up until its record stood for 18 centuries. Gunpowder blew the old fire-setting method apart in 1627. A shipworm, of all things, showed engineers in 1818 how to tunnel through mud without drowning. And compressed air, dynamite, and eventually rotating steel disc cutters took the whole practice from hand tools to machines the length of a city block. Was any of this inevitable? The evidence says almost certainly yes. Tunneling technology arose independently on nearly every inhabited continent. Ochre mines in southern Africa, flint mines in Europe, Qanats in Persia, copper mines in the Balkans, each one developed by people with no contact with the others, solving the same underlying problem in whatever materials they had on hand. Given how universal the needs for minerals, water, defense, and eventually transportation turned out to be, the probability that some human culture somewhere would eventually start digging on purpose sits well above 95%. The tools varied enormously. Antler picks in one place, pneumatic drills in another, but the underlying instinct never changed. Whatever the surface couldn't provide, people decided it was worth going into the dark to find. And that instinct never actually stopped. In 1963, a resident of a town in Cappadocia, in modern Turkey, knocked through a basement wall during a home renovation and found a room on the other side. Behind that room was another room, and another. What he'd stumbled into was Derinkuyu, an underground city carved 85 meters straight down into volcanic rock, 18 levels deep, with room for as many as 20,000 people, complete with stables, chapels, ventilation shafts, and 500-kilogram stone doors that could seal each level off from the inside. It had been sitting there in total silence for centuries, waiting for someone to break through a wall and find it. Which brings us back to those 2 rings of broken stone, 336 meters into a French mountain, built by hands that weren't even fully human as we define it, 176,000 years before anyone thought to write anything down. The Earth, it turns out, was always partly hollow. We just kept finding new reasons to make it more so. Somewhere beneath you right now there's a tunnel, a subway line, a sewer main, maybe a length of fiber optic cable carrying the exact data that put this video on your screen. Nobody thinks about it. But every single one of those tunnels exists because 43,000 years ago, somebody looked at a hillside, picked up a stone tool, and decided that whatever was inside that rock was worth digging for. They were right, and we never really stopped. This has been Ken. See you in the next one.